This video is designed to acquaint pilots with the operation of the Head-Up Guidance System, HGS, installed on the Embraer original jets. The HGS is an electronic display system that generates and projects information in the pilot's forward field of view. The system displays flight and navigational data that overlays the outside scene in an accurate one-for-one relationship. The system supports the following operations: low visibility takeoff and manual Category 3A approach and landing use HS guidance. Category 1 and Category 2 approaches using Flight Director guidance. Manual VFR approach. En route navigation. Display of situational awareness information including TCAS advisories, wind shear escape guidance, and unusual attitude. The HGS consists of HGS computer, control panel, HCP, overhead unit, OHU, combiner. The HGS computer receives input signals from other aircraft sensors and generates a symbology set that is dependent on the selected mode of operation. This symbology data is transmitted to the overhead unit in the form of deflected signals. The HCP is used for setting glide slope angle, runway length and elevation, and for selecting HGS active and standby modes of operation. It also provides an indication of the system's ability to provide Category 3A guidance. The OHU generates flight symbology in a cathode ray tube and optically projects the symbology onto the combiner. The combiner optically combines flight symbology with the pilot's view through the windscreen by reflecting the symbology image projected from the OHU. The HGS is operational when ground power or aircraft power is applied to the aircraft. When the HGS is not in use, the combiner may be stowed out of the pilot's field of view. To stow the combiner, press the release lever, grasp the combiner by the edges, and rotate it aft and up to the stow position. The combiner latches into the stow position and is retained until released by pressing the release lever. When conducting HGS operations, the combiner is placed in the detented operating position. Press the release lever and rotate the combiner to the operating detent position. When in the operating position, the combiner has a breakaway feature that allows the combiner to rotate toward the windscreen if there is a sudden deceleration of the aircraft. A latch holds the combiner in the breakaway position. The illumination of the combiner light plate is controlled by the overhead panel light control. The HCP front panel contains a display screen, numeric keypad, a fault indicator, and several control push buttons. There are 4 display lines on the HCP display screen. These lines display the active HGS mode, the standby mode, runway data, and the reference guide slope angle. Each line has 8 positions for text or symbols. The numeric keypad is used to enter runway and glide slope data. The fault indicator is illuminated when any of the HGS elements detects a built-in test failure. The HGS active mode can be changed by repeatedly pressing the mode push button adjacent to the display. The next active mode that will appear on this line is displayed on the standby line of the display. Similarly, the standby mode can be changed by repeatedly pressing the standby push button adjacent to the second display line. The sequence of modes that will be displayed is PRI, IMC, VMC, and, if available, A3. Runway length values can be entered between 0 and 99999 feet. Runway elevation values can be entered between -9999 and 99999 feet. The dim push button is used to enter the negative sign. Pressing the RWY push button on the HCP illuminates the dot annunciator on the upper left corner of the RWY push button and displays the current value on the adjacent line, preceded by either LN, length, or EL, elevation. The greater than symbol indicates the HCP is in the data entry mode. Repeatedly pressing the RWY push button toggles between the runway length and elevation values. The first value displayed will be elevation if the aircraft is in flight, or length if the aircraft is on the ground. The GS button on the HCP is used to enter the glide slope angle for the landing runway. Typically, this is the published glide slope angle or the desired glide path angle for a visual approach. Reference glide slope values between 0.00 and minus 9.99 C can be entered. For an HGS A3 approach operation, the reference glide slope value must be between the values of minus 2.50 and minus 3.00. Any other value will disallow the H3 status. No H3 indication on the HCP mode line following approach capture. Additionally, the reference glide slope value cannot be changed in A3 mode once the aircraft has descended below 500 AGL. Changing the reference glide slope value is performed in the same manner as the runway entry described above. Let us see other HCP functions. Pressing test starts or stops the HDS test functions and displays. The test functions are only available when the aircraft is on the ground. The CLR, clear push button, performs the following functions. To remove all symbology, press the clear push button. The dot annunciator on the push button is illuminated, and the letter CLR replace the current mode on the HCP display. To restore the combiner display, press either the CLR or mode push button. All other HGS functions continue normally. The clear push button is used as a backspace push button during data entry and test operations. In the test mode, the clear push button is used to navigate the displayed menus. To manually set the display screen intensity, press BRT plus to increase the display intensity or DIN minus to decrease the intensity. When the HGS is in the data entry, RWY or GS or test mode, these push buttons are used for other purposes.